Hello, welcome to the January 7th edition of the Better Buildings webinar series. In this series, we profile the best practices of Better Buildings Challenge and Alliance partners and other organizations working to improve energy efficiency in buildings. Next slide. I'm Eli Levine. I lead the U.S. Department of Energy's Better Plants program, and I'll be leading our discussion this afternoon. Today, we'll be hearing from three of the Better Plants 2019 Better Project and Better Practice Award winners to learn more about their innovative industry-leading energy management work. The Better Practice and Better Project Awards were created to recognize outstanding accomplishments in industrial energy efficiency at both the organizational and facility level. These three represent certainly three of our favorites, but a small subsect of the roughly dozen winners of the awards over this past year. So if you're interested in learning more about the other winners, I'll encourage you to visit our website. And if you're interested in learning about this upcoming year's winners at the 2020 Summit, for 2020, I encourage you to attend the Better Buildings Summit in June that I'll share more information at the end of the webinar. So with that, let me turn to our presenters. Panelist one, Blair Stern from Saint-Gobain Corporation. Blair is the Process Sustainability and Energy Manager for Saint-Gobain North America. In this role, Blair is responsible for the environmental sustainability goals of Saint-Gobain North America, which include efficiency goals for energy, waste, water, and greenhouse gas emissions across their North American manufacturing footprint of over more than 130 sites. He accomplishes these goals through the leadership of their Sustainability Champions Network, which provides programs, partnerships, and expertise to drive progress and build a network of capable leaders throughout the Saint-Gobain manufacturing groups. Blair leads this group and these initiatives with more than 12 years of manufacturing experience and more than 6 years in corporate sustainability and energy management. Secondly, Bruce Bartel from New Water. Bruce is the treatment manager at New Water in Green Bay, Wisconsin. Bruce has been with New Water for 35 years and has operated and managed all of the treatment processes. He has received New Water's Jack Day Award of Accomplishment and Peer Excellence Award. He is a past president of the Wisconsin Wastewater Operators Association and has received the association's Kobe Crabtree Award, which recognizes excellence and technical support provided to others in the field of wastewater treatment. He has an associate's degree in water and wastewater technology from Moraine Park Technical College and BS degrees from Lakeland College in business management and marketing. Our third panelist is Mark Minter from Agriper. Mark's the energy engineer at Agriper, one of the world's top 20 dairy processors. Mark has a degree in mechanical engineering from the University of Minnesota, Duluth, and has received his CEM, the Certified Energy Manager certification in 2011. For the past 6 years, he has been tasked with improving the energy efficiency and sustainability goals for all 10 U.S. Agriper cheese and whey plants. During that time, Agriper has reported over a 10% reduction in energy intensity by completing several energy efficient projects and renewable energy initiatives. So thank you all, Bruce, Blair, and Mark, for joining us today. I think I'll take a minute or two here to remind our audience, I want to remind our audience that we'll hold questions until near the end of the hour. Please send in questions through the chat box on your webinar screen throughout the session, and we'll try to get to as many as we can. The session will be archived and posted to our Better Buildings Solutions Center for your reference. So I think I'll take a few minutes now to walk through the Better Plants program in case you're not familiar with how Better Plants fits into the broader Better Buildings initiative. Essentially, Better Plants works with manufacturers and other industrial organizations to help them save money and improve their competitiveness through increased energy productivity, water savings, and our new waste reduction pilot. Next slide. Why do we care? Manufacturers spend over $200 billion a year on energy to operate our plants, and the Department of Energy data, from our national labs demonstrates that most plants have big opportunities to reduce their energy use with relatively short payback periods, and we see this as really important for for your resiliency, for your competitiveness, and for your workforce development. So we Really have enjoyed the program, and let me tell you a little bit more about it on the next slide. So how does it work? It's voluntary and it's no cost to participate. It's partners set these long-term strategic goals, typically about 25% over 10 years, and then DOE works with you to achieve your goal. You're paired up with a technical account manager based through our national labs who can help you identify savings opportunities and determine the best plan of action to achieve your goal. So throughout the program, we provide technical assistance and recognition, access to our national labs and innovation, and then the convening that comes from having 225 some odd partners when we like to facilitate the sharing of best practices like we're doing today. So next slide. Why partner with better plants? Consider partnering if energy is a significant part of your operating costs. You want or need technical assistance. Networking with industry sector peers and industry experts is helpful, or you're looking for recognition for your, we really like helping to amplify your story and share your successes so other people can learn from it, but also to bring attention to the leadership you're showing. So to start us off, let's hear from Blair Stern from Saint-Gobain with the compressed air competition they hosted. I was so excited to read about this. Saint-Gobain is doing so many fun and interesting things to engage their employees and make energy efficiency fun. So I'll turn this over to Blair to share his presentation.
Thank you, Eli. Can you hear me all right?
Yep.
Great. Well, as you said, Saint-Gobain is a large manufacturing organization with 130 sites all over North America, and I work within our sustainability network of those sites, working on energy, waste, and water and emissions projects. So I'm here to talk about the compressed air challenge that we did in 2018. So if you could go to the next slide. Just as some background, so why compressed air? As many manufacturing sites know, compressed air can be a very costly energy source within the sites. It's estimated that a half-inch leak can cost over $100,000 if left to run for a year. So certainly a lot of opportunity there. But in addition to that, we did a survey in 2017 of our sites to try and gauge what sort of areas they see need. And one of the major ones that jumped out was compressed air leaks, programs to help find those. One of the sites that you see here estimated that nearly a quarter of their energy was going to compressed air leaks. And many of our sites, we learned, didn't necessarily have great compressed air auditing programs or leak check programs or things like that. So if you could go to the next slide. So one of the many things we learned from that survey is that nearly all of our sites use compressed air, and probably many of your sites also. And in addition to that, a lot of those systems are rather old. We had almost a half of our sites that are relatively new, but 30 or 40% of those sites had systems that were nearly 15 years old or even older. Many of those were looked at as needing to be replaced in the near future and getting to the end of their lifetime. In addition to this, we had many of those sites, nearly half of those sites, that didn't have formalized compressed air leak checking programs or doing regular audits. So we saw a great opportunity for establishing a program to go after those leaks. Some of the suggestions that came out of our network was trying to find preferred vendors, implementing a detection or repair program, doing in-plant trainings through the DOE, which we also did. But one of the great ideas, if you could go to the next slide, was to make it fun, to have a compressed air challenge across our sites. At Saint-Gobain, we like to make things competitive. We like to make things fun. So we established a compressed air challenge over a couple months for any and all of our sites to participate in. And as you can see, the savings that we were able to find, both from energy and financially, were pretty significant across all of our sites. If you go to the next slide. So to establish this program, it was just a score point system of trying to find opportunities as well as to drive creativity. So we awarded points, as you can see, for naming creative team names and putting together photos or videos. We also wanted to institute continuous improvement type efforts. So we awarded sites that had recently completed audits or that had formalized programs. But then we also had a scoring system for the leaks that were actually found, and we wanted to award both finding those leaks but also fixing those leaks. So as you can see, we gave a couple points for the leaks that are found, but additional points for those that are able to be fixed and resolved. We also wanted to make it fun and creative and innovative, so we had some bonus points for sites that really took ownership of this and maybe created some of their own internal teams or gave out awards. So we wanted to award those as well. If you go to the next slide. So we communicated this out by setting up a tool for all of the sites to keep track of all of their leaks and submit those to us. And so this was the form that they were able to use to keep track of what's been identified, what's been resolved, to estimate those savings that we were able to track through this program. And this was communicated out to all of our sites through the Sustainability Network, which has a number of different ways of communicating. But this was the tool that we built to communicate out. Go to the next slide, please. As far as participation, we had 19 different sites participate in the challenge, and as you can see across our numerous businesses, we had good participation from a number of these businesses. So we saw quite a few sites that went ahead and scheduled compressed air audits, so that's a great result of this. A number of sites that also instituted their own tracking systems, as well as utilizing some of the resources that we have in our internal best practices tools. We also hosted a webinar so that people within our network could understand the process, learn best practices, understand how to work on their compressed air challenges. And as you can see here, we even had folks from sites that weren't necessarily participating in the challenge, but still wanted to learn and grow in their program at their site, even if they weren't able to participate. Next slide, please. So like I said, we wanted to communicate this out in the many avenues that we have. So we had weekly communications through email. We have had a webinar to talk through this program. So this is just one of the examples of how we communicated this out to our sites. Trying to make it fun by giving out awards, but also driving people to our internal sites for their resources and ways to develop their program at their sites. Next slide, please. So as far as participation, as you can see, we had participants from all over the different regions and within our businesses, and we had some fun creative names. But as you can see here, we had varying degrees of points and quite a few of them that really drove the needle, which was great to see. But many numerous leaks that were found, and a lot of these sites were able to fix the majority of those leaks. So great participation over the several months of this competition, and it came right up to the end as far as those top two leaders. You can go to the next slide, please. So as I said, we wanted to continue to drive participation throughout this period. So in addition to the final competition at the end by points, we also wanted to continue to push the initiative throughout. So we had different awards throughout that time period, early on just around having creative names and submitting photos, and then just getting things moving with finding your first few leaks and getting those resolved. But the intent here was to continue to drive emphasis on the program, to keep things fun and competitive and reward people for the work that they're doing, and give out a couple neat little sustainability themed awards to both keep things fun and competitive, but also reward those that are working hard on this. Next slide, please. So this is just an example of one of those communications. This was actually our internal website where we each week posted results from the competition so that the teams could see how they're doing and how their competitors are doing. Once again, keeping it fresh in mind, and also, driving that competitive spirit of seeing, those that are around you and trying to get ahead to be there at the top of the list. So this was on our internal website, and this is also where we had a number of the tools, both for compressed air and many of our other initiatives. So if you could go to our next slide, by posting the results there, we were able to also drive viewership of the many tools and help and assistance that we have on our internal website for our sites to utilize in their challenge, as well as to learn about the other resources available. If you could go to the next slide, please. So at the end of our several months of competition, it actually came up into the last few weeks. The team that won first prize here, a roofing site in North Carolina, they were in second place up until like the last few weeks. So a really exciting challenge. You can see there they found 146 different leaks and were able to fix many of those. So great achievements from this site, and we gave them a nice little prize of a solar charger backpack to reward their achievements. If you could go to the next slide. The second place team, which was leading right up into the end, also did great achievements there of finding 10 different or 100 different leaks and fixing nearly all of those. They had a neat little way of competing within their site to achieve this. Kind of a creative take on ours is they had a competition right there at their site between the different people to try and find leaks, and they ended up giving out awards just there at the site. So a neat little take on taking ownership of this competition and having their own little competition. Next slide, please. So in addition to these huge sites that have great opportunity and plenty of leaks, we also wanted to award some of our smaller sites that may not have as many opportunities for leaks and leaks to be resolved. So we had those different bonus points, and this site here in Texas was very creative and created a little YouTube video to both drive the competitive spirit but also make it fun. So you see there that they were also included in our awards. So a real neat way of driving best practices, finding opportunities for energy savings, but also making it fun and competitive across our sites. Next slide, please. And so we also had team name competition that again came up into the final hours. We put this to a vote, so any of the sites that were participating in our competition were able to vote on their favorite team names. So you can go down the list there and see a lot of fun ones. Voluntold, probably a common term in many of our corporate environments, and WikiLeaks. They were voting up until those last hours to see who was going to be the final first place winner for the most creative name. Next slide, please. And so, what's the whole picture here? So you saw on an early slide, we were able to find, significant energy savings and financial savings through just having this fun competition. All told, we found over 800 leaks and were able to fix almost half of those. And even fixing many of the more significant leaks here. So a great way to find, relatively easy savings, or at least, relatively low cost, just buying a bunch of awards and spending some time tracking these. We were able to achieve significant savings across the 19 sites that participated, getting roughly 5% of their energy spend at those sites. And at the corporate level, getting $2.5 million in potential savings for those leaks is pretty significant achievements for a fun competition. Next slide, please. So I guess, what advice would I give to those that are thinking about something like this? We're already starting to work on the next stage of this competition for this year. So more to come, hopefully, in future DOE events. But the advice would be to keep it fun, make it competitive across your sites, find opportunities to drive improvement and best practices in fun environments like this compressed air challenge. Utilize the resources that are out there. We used a number of DOE resources, but there's plenty of good resources out there. And it also helped to institutionalize a lot of this. As you saw, a number of sites had audits of their compressed air systems or instituted leak detection programs So the hope here is that it's not just a one-off, that we're instituting a program that continues on, and there's continuous improvement of those leaks as those pop back up throughout the years. But a great way to get energy savings with a quick little competition. And as you saw there, not insignificant savings that we were able to achieve in these few months of fun competition. So that's an overview of our program. I look forward to any questions you may have at the end. Thank you.
Hey, great. Thank you so much, Blair. Now let's hear from Bruce Bartel with New Water on their solids handling facility replacement at their Green Bay plant. Bruce?
All right, can you hear me, Eli?
Yep.
All right, next slide, please. All right, I'm going to talk about our resource recovery electrical energy project that we undertook here at our wastewater treatment facility. R2E2 is the short name for it, and yes, that is a takeoff from Star Wars that we came up with that. Next slide. Just who and what we are. We are New Water. We are the brand of the Green Bay Metropolitan Sewage District in Green Bay, Wisconsin. New stands for Northeast Wisconsin. We are more than just Green Bay, which we'll get into a little bit later. It also stands for for New Water. We take wastewater that comes into our plant, clean it up, and put it back into the environment as New Water. And that also stands for nutrient, energy, and water, where we want to recover whatever we can from what is sent to us. We do operate two facilities, 24/7, 365. The facilities are about 7 miles apart, and we are governed by a 5-member commission that is appointed by the Brown County Executive. Next slide. So this is our vision statement, protecting our most valuable resource, which is water. Next slide. So a little bit more about us. We are a wholesale provider of wastewater conveyance and treatment services. Our service area is on the map there in the green or the blue. We have 15 municipal customers. Population we serve is about 232,000 people, and we have 2 direct industrial customers. Our service area covers 285 square miles. We are the 3rd largest wastewater treatment plant in Wisconsin, behind Madison and Milwaukee. And on average, we treat about 38 million gallons a day. You can see the Green Bay facility right at the mouth of the Bay of the Green Bay, where the Fox River discharges into the Bay of Green Bay by the yellow arrow. And then a little bit south of there, about 7 miles south, is our De Pere facility. You can see the yellow arrow or star in the De Pere area. Next slide. This is an aerial view of our Green Bay facility, which is our main facility, where we treat on average 30 million gallons per day. Next slide. Aerial view of our De Pere facility, where we treat 8 million gallons today or per day. The De Pere facility is just a wastewater treatment process. All the solids that are generated in the process are pumped to the Green Bay facility for the solids handling, for all the solids handling at Green Bay, and that is the project we'll be talking about. Next slide. So the R2E2 project, this is the architectural rendition of the building and the digesters that we put in. It was our most cost-effective solution to replace our solids handling at the Green Bay facility. And also, it's a shift in how we treat, how we look at wastewater. It's been a shift in our industry probably over the last 10 years, that instead of just being a place that disposes of whatever is sent to us, we want to treat everything that comes to us as a resource and to recover whatever we can from that resource that is sent to us. Next slide. There are three main drivers between or for this project. We had an aging infrastructure. In the photo to the left with the orange and white stacks, that is our old or existing building, which is currently being demolished right now. And to the right is our new building and new digesters that we put up. But we had an aging infrastructure where the incinerators that we use to take care of our solids went online in April of 1976. So they were 40 plus years old, which is well past the life expectancy of that type of equipment. We had to meet environmental regulations from the EPA. They came out with more stringent air regulations in March of 2011, and we had to meet those by March of 2016. So we had to meet those regulations, and then we had to increase our capacity needs. Green Bay and De Pere used to be two separate wastewater treatment facilities. When we merged the two facilities, we were operating at 90% capacity, so we had to increase our capacity in order to continue to serve the communities that we do serve. Next slide. So what is included in our R2E2 project? We had an anaerobic digestion, a new solids building, dewatering of the biosolids with centrifuge, a dryer, biogas storage. We also generate electricity on our own. Nutrient recovery system was added. We do not have that up online yet. That is still undergoing commissioning. And then we put in a new fluid bed incineration and then a state-of-the-art air pollution control technology to go with the new incinerator. Next slide. This is another view of the new solids building. You can see the digesters off to the left of the screen, and then the new solids building right in the forefront there. Next slide. This is the top view of the new fluid bed incinerator that we put in. It is a high temperature fluid bed incineration system that replaced our two existing incinerators that we had. Next slide. This is the fluid bed incinerator system overview. We'll go quickly from left to right. So we have centrifuges for dewatering of the biosolids. We go through a scalping dryer, which takes the biosolids from about 20% solids, which is 80% water, increases that to about 35 to 40%, and that is pumped into the fluid bed incinerator. We take the thermal oil, we heat the thermal oil off the flue gas, off of the incinerator, and then we run through our pollution control train, as you can see in the blue and to the right, pretty extensive pollution control train. And then we have a ash is the byproduct of the incineration process, and we have an ash collection tank and an ash storage tank. Next slide, please. This is the top view of the dryer that is used for the biosolids. So it's pumped into the biosolids from our centrifuge dewatering, goes through the dryer, drops down a floor to the conveyors that you can see toward the bottom of the screen, and then is pumped into our incinerator. Next slide. This is a view of our digesters. We put in two digesters, mesophilic digestion, which is really digestion about 95, 96 degrees Fahrenheit, where we run our digesters. That is used to produce biogas and also to reduce the solids. We have two silo-shaped digesters. They are 110 feet tall, 2.2 million gallons capacity for each. And we also have high-strength waste that we can receive. So high-strength waste is like a dairy waste, a sugar waste, glycol from the de-icing fluid at the airport. Is all good stuff that we can feed our digesters. And really what it does, it gives the bacteria in those digesters, it basically puts them on a sugar rush, and they actually will increase the biogas by the high-strength waste that we put in. Next slide. Just another view of the digesters. They are 110 feet tall. Most of it is above ground, but there is probably a good 50 feet that is below ground. Next slide. So this is another view of the digesters. The gas below the digesters on the bottom part of the screen is the biogas cleaning system that we have. And then the bulb or the dome that you see is our biogas storage. We have about 20 minutes of biogas storage, which is basically a wide spot for us for the biogas to get into our energy recovery system. Next slide. So the energy recovery is part of the project for R2E2. We produce enough biogas to run two 2.0 megawatt internal combustion engines. We capture the heat from the engines, and we use that to heat the digesters to the 95, 96 degrees. We take the heat recovery from the fluid bed incinerator, and we use that through a thermal oil system to run the dryer. And then we have autogenous incinerator operation, which means we do not use any auxiliary fuel. The previous incinerators, we were using quite a bit of natural gas. And then eventually we'll get to the point where we are recovering nutrients from our wastewater stream and producing a fertilizer product. But we do not have that system up online yet. Next slide. This is a picture of one of the internal combustion engines that we have that are 2 megawatts each. Next slide. So the benefits of the project, it really addressed the original project drivers. We had that aging infrastructure. We've taken care of that. We have done testing of our air emissions, and we are within the regulations. We also have increased our capacity needs. When we looked at this project, we started out with looking at 72 different technologies that we could use, and this plan here turned out to be the lowest cost plan over a 20-year planning period, and we hope to eventually get to about 50% of generating our energy needs at our Green Bay facility on site instead of coming off the grid. Next slide, please. So this is our energy data. So in November of 2018 is when we first got we started producing biogas, had the digesters started up, and then also had one of our IC engines running. So we were about 93% that we had purchased, and it only had generated about 7%. And then if you look to October and November of this past year, we purchased about 60% in October, generated about 40%, utilized about 86% of our biogas. And then in November, we were a little bit less for what we had purchased and generated more and utilized about 75% of our biogas. So that is pretty typical about where we're running, where we're generating about between 40 and 45% of our energy needs, not quite to the 50%, which is the goal, eventual goal that we're striving to get to. Next slide. This is just a visual graph of our purchased electricity, our generated electricity, and then the biogas use. So the blue part is what we have purchased from November of 2018 and then on to November of this past year. And then the red or the orange is what we generated on site. And then the biogas utilized is the green line that we percent that we have utilized. Next slide. I always like to show this slide. This is our 1935 original plant that we had at our facility, and I call this Back to the Future because if you look at what they had back in 1935, They had digesters, they had methane storage, and they were running internal combustion engines and generating some of their own electricity on site. So if I look at that, I think, wow, that's pretty cool for 1935 facility. Next slide. As you know, being in Wisconsin, we do face some winter weather. So this is just a photo of one of our operators being out in the plant with a smile on his face, cold weather, taking care of things out in the plant. Contact info is there if you do want to contact me, and also you can connect with us on the various social media sites. Thank you.
Great. Thanks so much, Bruce. Really appreciate it. We're getting some of that winter weather here, but nowhere near as much as you guys get in Wisconsin. So a quick reminder to send in any questions you may have through the webinar chat box on your screen. We're collecting those for our Q&A period at the end of the session. Now we'll hear from Mark Minter on Agriper's ammonium systems for cooling processes in their plants. Mark, tell us more.
Hi, yeah, thanks. You go to the next slide. We are Agriper, and like you said, we were out at your Better Plants thing you had. So next slide, please. We are one of the top 20 dairy processors in the world. We have plants in both the U.S. and Canada. In the U.S. here, we mainly have cheese plants, and then we dry the whey that comes off those. So a little bit about what we do. Next slide. So in the cheese making, we do use a lot of cooling for things such as pasteurization of the milk, evaporators, refrigerated warehouses, and several other areas within the plant. So to do this, we use ammonia systems. At our Le Sueur plant, which is what we're talking about here today, we had historically ran at a 20 psi suction pressure. And that was in order to build ice in a rooftop ice bank. That ice bank then supplemented 2 undersized plate and frame heat exchangers to provide the plant with 35-degree chilled water. To do this, we used 3 400 horsepower ammonia compressors, and those ran year-round. We were lucky that we had these on amp logs, so we could trend the data throughout the year. And we could see even winter, summer, it didn't matter. All 3 of those compressors were running at all times. And then using that amp data, we were able to see that we used over 5 million kilowatt hours a year, or at our electric rates, that was nearly $400,000. So we knew there was quite a bit of an opportunity there. And we also knew that looking at some of our other plants, that they typically could run a suction pressure around 30 to 35 psi. So here in Le Sueur, we're at 20. So why was that? Next slide, please. So when I go into our plants and do energy audits, we do energy audits at all our plants. This is one of the most common things I hear is, well, that's the way we've always done it. We've always had a 20 psi suction pressure. But there's better. We have proven at other plants that we don't need that. So what was the limiting factor here, or the reason? So next slide, please. We contacted ACNR specialists to conduct a very thorough audit of the system. They identified 2 ways that they thought they could mitigate the problem. Both of the options they gave us would allow us to raise our suction pressure to 35.6 psi. And for those who don't know, the difference between the suction pressure and the discharge pressure is what we call the lift, and reducing the lift reduces energy consumption. And then importantly, it also increases the capacity, so you can get more cooling out of each compressor that you're doing. So the 2 options they gave us, next slide, please. Option 1 was to Basically install a new plate and frame heat exchanger, similar in size to the existing two. So our existing system is there on the left. You can see we have the two plate and frame heat exchangers with an ice bank generating 35-degree water. The proposed system here was to basically eliminate the ice bank and add another heat exchanger. We were able to do that because, or we would have been able to do that because the heat exchanger is more effective or efficient at transferring BTUs than an ice bank is. We weren't really using the ice bank for the main purpose it was designed for. But anyway, that would have required us to install a heat exchanger inside our facility where we didn't really have room, where the ice bank was on the roof. So that option wasn't really going to work. So next slide, please. The other option they gave us was to basically remove the entire system and remove both heat exchangers and the ice bank, and then install new heat exchangers in the spot where the old ones had been. That way we had the room for it. And we could also eliminate the ice bank. And as you can see here, that would allow us to raise our suction pressure to 35 PSI. So that is ultimately what we went to. But there are a few obstacles, and next slide shows what some of those are. As I said, we were limited on space. We had to remove the ice bank, which we're in Lesueur. It's a small town, and we're right on the main road here, so that requires getting a crane, shutting down Main Street. It could be for up to a day to do that. We also needed to increase the pipe size to the heat exchangers, which that just adds costs and things. Then we also had to come up with a way to show savings, because everything we do, I have to, show what the payback would be. And then that ultimately has to go up in front of my manager and get approved. So what I did, I used the Vilter Screw Pro software, and I tried to be very conservative, where I estimated, roughly 1 million kilowatt hours saved. I plugged in several different scenarios, because your suction and discharge, or here suction pressure would stay the same, but discharge pressure varies throughout the year, because we do float our head pressure. And then I had to contact the utility because we wanted some rebate dollars. And on a project this size, you need pre-approval, or else here anyway, we'd probably get denied. So we went through all that, got the project approved through our managers. Next slide. Here I'm trying to show the old heat exchangers on the left. They're smaller. You can see they're dirty and everything. The new ones on the right there, they're much larger. It's kind of hard to tell on that, but you can see we're really limited on space. Not a lot of space inside our facility, so we were a little unsure at first whether they would fit or not, but they did ultimately. And then next slide. Now you might have to click a few times. It looks like not all the lines got added here, but we started gathering some data. And for me, this is what I like to see. So the blue dots are the total amps on the system before. The red line is the average. And then after we did the project, the total amps on the ammonia system is in the orange dots. So you can see our average really dropped a lot. And that was throughout all different temperatures. We actually measured it for like 6 or 8 months, and that's the data we got. It showed, or we could prove, because we had it all logged, that we were over 2 million kilowatt hours saved, which then that triggered a formal measurement verification from our utility. But luckily we had all this data, so I just sent it to the state. They reviewed my calculations, the data, did a few spot checks, and ultimately we did get approved for a $64,000 grant or rebate through our local utility here. And then most importantly, on top of all that, we are saving $157,000 a year. And that's something that happens every year. You get your rebate one time, but the annual savings are what really can be huge. Next slide. So the next steps we're doing is we're going around gathering data at all our other plants. This can be easy at some, hard at others where we don't have the trends and logs. So we're getting those installed and trying to get some of that up and running. Our one plant in Drum, Idaho, we did do a test run. We're still doing it actually, where we raised our suction pressure by 10 psi, and we're trying to see what kind of savings we can get there. Right now, we're showing pretty good savings at that plant. Two of our other plants, we're looking to lower the discharge pressure. And again, that will also reduce the lift, which reduces energy. So we're trying to find ways to do all this at our other plants and make our ammonia and our refrigeration system as efficient as possible. I think that's it for me.
Sorry. Thanks, Mark. That's great. I find it so interesting, just as an aside in the program, working with folks from industry from so many different sectors who are working on all of their challenges and really showing great leadership, but working in so many different ways, and that so much of what they are working on hopefully can be replicated, or at least the lessons can be shared across our program. So we're going to have question and answers in just a moment, so please go ahead and enter your questions into the Q&A box on the side of your screen. Before we dive into these questions, I'd like to highlight how to find additional resources relevant to this presentation. To find resources from the Better Plants program, visit the Better Building Solution Center. You can explore by topic, solution type, or go to one of our programs and partner pages directly. So I believe the screen's moving as I talk, but here's how you can find the Better Plants tab filled with various resources. One of our most popular pages is our technology focus area pages, so you can browse and find more information on specific technologies. So whether it's compressed air or pumps, steam systems, or whatever, it has all of our case studies, all of our technical resources and tools we've developed, who the experts are through our program to reach out to. I really do encourage you to take advantage of this. Go to energy.gov/BBSC to explore all of the Better Buildings, to explore all that the Better Building Solution Center has to offer. All right, so let's go ahead and take some questions from the audience. Well, as we get started and we're pulling up the list, one question that I had, Blair, do you think that this was really great leadership that you guys showed on compressed air? And I know that's one of the consistently biggest challenges that our manufacturers are facing. And the way that you did it in terms of engaging different plants and really turning it into a fun competition, do you think this is something that you might replicate for other areas, other areas that you might want your plants to turn their focus to?
Yeah, that's a great question, and as I alluded to towards the end, we're in the process of developing the next phase of this, which is to build beyond just compressed air into other opportunities, whether that be energy, waste, or water. But again, building on this same structure of making it competitive across our sites, building a scoring system for those who participate and giving out awards, but not just looking at compressed air, but expanding the competition into other areas. So yeah, great question, and one that we're working on to roll out this year. So hopefully it's something we can present on in a future webinar.
Awesome. Yeah, that's great. We'll for sure be in touch with you guys. We've got a whole bunch of questions, and I'll try to fire through these as quickly as possible. To Bruce, how many cubic feet per day of biogas do you guys produce? Is the biogas pipeline quality, or do you need to do additional treatment?
So we produce about 6,500 CCFs or cubic feet per day. It is not pipeline quality. We had looked at that a little bit after we had started planning for this project about getting it to be pipeline quality. We have explored that a little bit, but not to any real extent. And then as far as gas cleaning, we do have siloxane removal. We also have H2S removal. So we do have pretty good clean biogas that we are sending to our engines.
That's great. Really interesting. Mark, on the ammonia system, do you guys have a way to free cool or to operate the system without running the chiller compressor?
We do not have any way right now to do any free cooling. You know, I've looked at that or thought about it, even especially in the warehouses or something like that, being in Minnesota, that it does get pretty cold here. But no, at this time, we don't have any way to get the free cooling. That would be nice in Minnesota.
Yes, for sure. Blair, one question we got for you. Finding and identifying leaks is easy. Fixing them seems to be the more challenging part. Why is that? And what are some of the ways or best practices for fixing leaks?
Yeah, great question and good point. Whoever submitted that has certainly worked at a plant. Yeah, finding them can be easy. Staying ahead of them is always the challenge. You know, compressed air is always finding ways to leak out, and so it is a continuous issue. So the advice that I would give is to try and institutionalize these sort of things, having routine walkabouts if possible, you know, compressed air checks for leaks to stay ahead of leaks, because they're always going to pop up. And so if you can have a program that regularly goes and tags leaks, and then submits, you know, maintenance requests, or even if it's your maintenance department that's in charge of that, because you know, any compressed air systems, there's always going to be little leaks. So trying to get out there and find them, you know, where applicable, replacing lines, repairing lines, you know, to get ahead of those leaks as best you can. It's always a challenge, so anything you can do to institutionalize the program is gonna help.
Yeah, I totally agree. Bruce, two sort of somewhat technical questions for you. What accounted for the dip in August on the energy utilization graph? And have you considered using thermal oil for something like an organic raking cycle turbine?
So for the dip in August, we were having some issues with our IC engines for that month, and so they weren't running all the time. We typically run one engine right now. We're just not producing enough biogas to get both of them online, which is something we're still working toward getting. But so that was the reason for the energy utilization dip there, was the fact that we're just having some issues which have been repaired. The manufacturer has been very responsive in getting our units up and line and keeping them running. And as far as the organic Rankine cycle turbine, we did look at that when we looked at our project. Do we go that route, or do we go with the IC engines? So we also had looked at micro turbines, but with the organic Rankine cycle, we started planning for this 10 years ago, almost 11 years ago, and at that time it just wasn't new enough or proven enough technology for us to invest in.
That I get it. I get you. That makes a lot of sense. So we're coming up on the top of the hour. I guess I'll just ask one final question to all three of you. You know, obviously these were some really successful projects and practices that you guys had put together. They really turned out successful, which is why we were so excited to recognize you for your leadership. If you could go back, knowing what you know now, having gone through the process, I'm sure it looks easy now, but you know, for all three of you, I'm sure putting things together like the scale of all three of your efforts was a pretty big lift. So if you wanted to pass along some of your wisdom. I definitely noticed when I was reading Bruce's bio that he received the excellence in technical support. So no pressure here. But if you had to pass along some advice for colleagues in our Better Plants family or in the broader community, what were if you had to do these projects again, or if you had to institute these programs again, what would you do differently, or what would you recommend to someone else trying to replicate your work? Blair, I guess Mark, I'll let you go first.
What would I do differently? Possibly look at, maybe look at some free cooling. It's tough in Minnesota. It's real tough on a ammonia system. We were real limited on space, so we didn't really have a lot of options to begin with here. But we kind of went with our main option that we had, really. It just was getting people to buy in and go with the change that we were suggesting, because when you're suggesting change, that's when you get a lot of pushback from plants. That's when you see, well, that's where we're going to have issues. That's where, things are going to start breaking, or we're not going to get the temperatures we need in different areas. And so just trying to get through all that was definitely our biggest struggle.
And what do you recommend? What ultimately proved successful in getting folks bought in?
The energy savings that I was showing, the rebate definitely helped too, because we've gotten a lot of those through our utility. So we were pretty confident that we at least get, the rebate dollars, and then the energy savings. That's and there's been a big push through, corporate down to really push some of these energy projects along. So that helps too, is getting manager buy-in, definitely.
Excellent. Yeah, that's really a great answer. Blair, I'll turn to you next. What would you recommend if other folks wanted to replicate your program, or what if you could do it again? What lessons did you learn along the way that would help make this program successful?
Yeah, I think one of the big things for us was, if we had to do over again, maybe standardizing the estimate methodology that we provided guidance for sites on how to estimate, the volume of leaks and the cost savings of leaks. But some of our, mature sites had their own tools and ways of estimating those. But it made it somewhat more difficult to combine the information when it may or may not be fully apples to apples comparisons, depending on how they're doing those estimates. So that might be one of the feedbacks I would provide. And then just the scoring. I mean, I think doing the weekly scoring updates was great in driving emphasis and competitiveness. But it's also some work. So you have to think through. Maybe bi-weekly might be better. Just for workload, but it was a great way to drive competitiveness.
Really cool. All right, Bruce, to you.
Yeah, I'm going to steal this from somebody else that told me this. Ingenuity is hard, and I think that's what we experienced here. All our processes that we put in are very common in the wastewater field, but to combine the two is very unique. So to have digestion and then incineration and a dryer is all unique. So we have worked through we've had to work through a lot of issues, and we continue to work through a lot of issues that we have had with the project. I think the biggest thing that I don't think I anticipated, I realized how big a project we were going into, and I realized what it was going to take, but I'm not sure all of our operators realized how big a task this was going to be. And I didn't anticipate the frustration that they were going to have, and working through all the bugs to get the systems up and running and online. We have worked through it. It's certainly gotten better, but I think that was probably the biggest thing that I didn't anticipate, was just the challenge that the operators we're going to face. I mean, I knew it was coming, but I don't think they realized it. And I would have liked to have prepared them a little bit better for that.
Awesome. That's really great answers from all of you, and continued thank you for all three of you for lending your time today. So just wrapping up here, I wanted to share this slide about the upcoming 2019-2020 Better Buildings webinar series, where we're taking on the most pressing topics from energy professionals. We've had a great turnout today, and we have some other really interesting webinars scheduled, or if you're interested in any of the previous webinars, they're all available online for you to go back and take advantage of. The very next webinar on the next slide is, we hope you'll attend. It's February 4th from 3 to 4 p.m. titled Save Money and Build Resistance with Distributed Energy Technology. This webinar will introduce 2 tools used for assessing potential facility level energy technology improvements, the Distributed Energy Resources Customer Adoption Model and REOPS Lite. I'm a big fan of REOPS Lite. DOE's national laboratories developed and used these tools to analyze potential energy investments at existing Better Buildings Challenge partner facilities, learn the results of their completed analysis, and how these publicly available tools were able to help the energy managers and other decision makers optimize the unique energy needs of the facilities. And then lastly, we're pleased to announce the date of the 2020 Better Buildings Summit being held in Arlington, Virginia from June 8th through 10th. In addition to engaging in interactive sessions, attendees can look forward to the return of Ask an Expert, building tours, and opportunities to network with their peers. It really is a special conference that is unlike many of the other sustainability conferences out there in terms of bringing folks together and allowing them to share with each other, and moving away from just having to sit there and be talked at, but to really be able to work across with each other and share best practices and ask the tough questions. So explore the session tracks and book your accommodations on the Better Buildings Solutions Center, and mark your calendars. Registration opens with special early bird pricing in 2 weeks on Tuesday, January 21st. So next slide. With that, I'd like to thank our panelists one more time for taking the time to be with us today. Feel free to contact the presenters directly with additional questions, or if we couldn't get to your question during the Q&A period. If you'd like to learn more about the Better Plants program or the Better Buildings Challenge and Alliance, please check out our website, or please feel free to contact me directly at the email shown. For any general inquiries or program support questions, click on the green icons and they will direct you to the appropriate contact. I encourage you to follow the Better Buildings Initiative on Twitter and LinkedIn for all of the latest news. You'll receive an email notice when the archive of this session is available on the Better Buildings Solutions Center. So thanks everyone, and if you're traveling somewhere with inclement weather, get home safe. Have a great day.